Question 11 reads, a ball of mass m traveling at velocity u collides with a stationary ball of mass m. After collision, the two balls travel at velocities v and v respectively in the direction shown. A student writes 3 equations relating to the collision. Which row in the table indicates the correct and incorrect equation? If we consider that all of the momentum is in the horizontal direction, and you're mindful of the statement of the law of conservation of momentum that says in any direction, the total momentum is constant, that in any direction is crucial here to getting the correct answer. It looks like this second column here is considering the vertical components, like mv sine 30, that would be the vertical component of the momentum here, is equal to capital M, capital V sine 40. So that would be like the vertical component of this object's momentum. And because there is no initial momentum in the y direction, they have to be equal to each other, right? Like all the momentum up is equal to all the momentum down in this object, because the 0 has to equal 0. In other words, if there is 0 initial momentum in the y direction, then the only way to get 0 momentum in the y direction afterwards is if the up and the down momentum are equal to each other, right? They cancel out. And so this equation is correct. And so we could say, well, it's either choice A, B, or D. We can eliminate choice C because that's a good equation there. If we consider now the horizontal direction, that's where the momentum comes from, this first object, mu. So mu equals, now what correctly gets the final sort of momentum there? Well, here we have mv cosine 30, okay? That's the horizontal component of momentum from this object. And then we have mv cosine 40 would be the horizontal component of momentum for this object. And the sum of the final momenta in any direction has to be equal to the initial momentum in that direction. And so that is a correct equation. And so we'd say, okay, so either A, they're all correct, or D, those two are correct, but the first one is wrong. And so the key idea here now is that the momentum calculations are dimension independent. What's happening in the y, what's happening in the x, sort of separate, right? Even though they move along these actual vectors. This equation that just says the initial momentum of this thing is equal to the sum of the momenta of the final things is not correct, because nowhere in this equation does it account for the direction that those momenta, sort of the components of that momenta is acting in. And so the correct answer to this question is choice D. The first equation is incorrect, but the second two are the way you need to deal with questions like this. Dimension independent. What's happening in the vertical direction? What's happening in the horizontal direction?